Hello everybody. In this video, we're going to go over example 6 from topic 2, lesson 3. And in this one, we're going to write the equation of a parabola in factored form. So they gave us 3 points. So this is almost like, let's go to the smart notebook. Let's leave from the last example and go into this one. So it's kind of like they're giving us kind of hints here. So let's see the points that they gave us. All right, so they gave us -2 and 0. So -2, 0 would be roughly right there. -1 and 0 would be roughly right here. And then they gave me -3 and 20. And remember from the last example, from example 5, I might need to move that 3 over just to make this work a little bit better. From example 5, I know this is not drawn to scale at all, but from example 5, we know that all of this on the left side before we hit -2, so when x is less than -2, we're going to be positive. Between -2 and man, I totally did not draw that correctly. Hold on. -1, let me move this guy over. -1. We are negative. And then when x is greater than -1, we are positive. Okay, so factored form is usually f of x equals some constant times x plus a. Oh, no, let's not use a because I'm using a here. Let's do x plus p, x plus q, and that would be my factored equation. All right, so let's see here. I have an x equals -2. I'm going to make this to 0 to get the factored form. So I'm going to add 2 to both sides. So I get x plus 2 equals 0. And this will give me my first factored form. Then I'm going to do the same thing when x equals -1. I'm basically reversing what we did to solve. I'm reversing it to get my factors back. So I'm going to add 1. So I get x plus 1 equals 0. Again, here's a factor. Now with this, let me scoot this over. With this, I still have to find this a coefficient because remember the a coefficient is either going to be a stretch or a compression on my graph, and this does affect how these cross through points. So the way I'm going to find the a is I'm going to use the third point that they gave us. It'd be pretty hard not to find a if I did not have another point of the graph. If I only had these 2 points, it would be near impossible to find a. But we do have a third point, and this is where the third point comes into play. So in this one, f of x, or the output of our function, is equal to 20. The input to our function is -3. So I'm going to plug in that -3. And I get 20 equals a times, that kind of looks like a 9. Let me try to make my a look a little bit more a-like. -1, -2. All right, so then I get 20 equals 2a, because negative times a negative is a positive. 1 times 2 is 2. Divide by 2, and I get 10 equals a. Substituting that back into my function, I'll get f of x equal to 10x plus 2 times x plus 3. Do they want it in standard form? Nope. Factored form is perfect fine. If I were to do it in standard form, if I did ask for standard form, I would do FOIL, or basically, if you want to think about it, x squared plus p plus q, x plus p times q. So 5 plus 5x plus 6. And then you factor in the 10. So always do the FOIL and then the distribution. So this is 10x squared plus 50x plus 60. So this is standard form. This is factored form. Those are all the forms. Let's look at the books, because the book does have you answer these in specific ways. And they kept theirs in factored form, which is perfectly fine. But here's our answer. All right, guys, so if you have any questions, please get a hold of me. I will be available when you get a hold of me. So I hope you guys have a fantastic day, and we will see you in... Oh, wait, one more thing before I sign out. Sorry. Just about to sign out. You're like, I'm ready to go. But there are concept summary. I did add this. And basically, it's going over everything that we went through in this chapter, what factored form is, what the graph looks like, how you could find the zeros from the graph. And you can actually we did find factored form from a graph. So this is a second way of basically factoring your equation. So yeah, there you have it. All right, guys, have a wonderful day, and I look forward to seeing you again.